Hello friends, so here is another question on electric field. So the question is that a pendulum bob has a mass of 80 milligrams and it carries a charge of 2 into 10 to the power minus 8 coulombs. It is at rest in a horizontal uniform electric field of 2 into 10 to the power 4 volts per meter. Find the tension in the thread of the pendulum and the angle it makes with the vertical line, the vertical axis. Okay, so this is the data, this is the information. Like I said in all the previous questions, the most important step is to read the question carefully, understand it, convert it into an accurate, clean diagram. Okay. So we have been given that we have a pendulum bob. Let's say first let us draw the axis, okay, because that will be very important here. This is, let's say, the horizontal axis, okay, and let's say the pendulum bob is here. Okay, and this is the vertical axis. So here the pendulum is, let's say, is suspended from this point. So let us point of suspension and this one, and here let this point of suspension be, let's call it O, okay, and we have been asked what angle it makes with the vertical, so let us name this angle as theta. This angle, let's call it as theta. Let the tension in the thread be this, directed like this. This is the tension in the thread. Okay, now it is suspended in a uniform horizontal electric field, okay, like this in this way. The electric field is like this, horizontal uniform electric field. Pendulum is suspended. So here a number of forces will be acting on this pendulum bob, and our job is to balance these forces, resolve them into the horizontal and vertical axis, and then get the solution. Let us see how we'll do that. So the first force that will act on this pendulum is the horizontal electric force, because it carries a positive charge and electric field always from positive to negative like this. So this will be the electric force acting on it. We know electric field is equal to force by charge, so force is equal to QE. So this is the electric force acting on the pendulum in the horizontal direction QE. Then we can resolve this tension force acting along the thread carrying the pendulum, which is connected to the pendulum, into horizontal and vertical components. Okay, first one will be acting along the vertical axis upwards. This is the tension force acting along the vertical axis, T cos theta, okay, the vertical component, and this is the horizontal component, T sin theta. Then another force that is acting on the pendulum is the downward force of gravity, okay, mg, where m is the mass of the pendulum. Okay, so these are the forces acting on the pendulum in this position. Okay, So it is balanced by a lot of forces that are acting: the downward gravity force, the electric force because of the electric field, the tension force. So we have to balance them out. So here, if you see, if we in the equilibrium position, this net force in the horizontal direction, that is T sine theta, it balances out the electric force QE because it is at rest. It means the net force on it is 0 in the horizontal direction. Similarly, in the vertical direction also there is no movement, it is at rest. So T cos theta, the vertical component upwards, is balanced by mg, the vertical component downwards. This. So here, if we divide these two equations, T sine theta by T cos theta, it will be equal to QE by mg, where tan theta is equal to QE by mg. So now all we have to do is put the values of these. Here Q is equal to 2 into 10 to the power minus 8 coulomb. Electric field is 2 into 10 to the power 4 voltmeter. Mass is 80 milligrams, which is around 18 10 to the power minus 6 kgs in MKS units. And then we have G, which is 9.8. So here it will be, if we put the values, we will get 2 into 10 to the power minus 8 into 2 into 10 to the power 4, 2 into 10 to the power 4, yes, not 3, 2 into 10 to the power 4 volt per meter, which is the electric field. Then the mass is 80 milligrams, which is 8 into 10 to the power minus 6 kgs in SI units. And G is acceleration due to gravity, 9.8 meter per second square. So if we calculate it, I'm using a calculator here. So it is coming around 2 into 10 to the power minus 8 to the power 4 divided by 80 into 10 to the power 6 into 9.8. It is coming around 0.51. That implies theta is equal to tan inverse of 0.51, which is coming around 27 degrees. So first part of the actually the last part of the question is solved. The angle which it makes with the vertical, this angle here, which it makes with the vertical axis, that we have found out 27 degree. Now we'll use this to find the tension force. So here you can use any of these equations, T sine theta equals to QE or T cos theta is equal to mg, to find the value of T. So we'll be using T sine theta is equal to QE. So T is equal to QE by sine theta, and that is equal to 2 into 10 to the power minus 8 into 2 into 10 to the power 4 by sine theta, which is sine 27 degree, which is equal to 8.81 into 10 to the power minus 4 Newton. That is the tension force acting along the thread carrying the pendulum bob. This is the answer. The first part of the question, this is the second part of the question, the theta value where we calculated theta, yes, this one. This is the last part, the second part of the question which was asked. Okay, so both of the answers we got. So it is a very good question. Each of these questions, in the previous one also we used the basic equations of kinematics. Here also we used basic concepts of mechanics, Newton's law came into play, everything. So it's a very good question, combining all the concepts, basic concepts of physics. So initially, just first in the equilibrium position, first thing to identify all the forces acting on the pendulum, resolve them into horizontal and vertical components, then just balance them out. Because it is in equilibrium position, they will cancel each other out. then get the value, use them to get the value of this angle theta, which we did, then use the value of theta, put it in one of these two equations to get the value of tension, capital T. Okay, so we did that.